What is meant by torque? Generally, what is meant by force? Force is a push or pull of an object. That's the basic definition. What is from the formula? F equal to ma. When an object moves in a straight line, then force, mass, and acceleration is there. If an object is rotating, for example, let's consider a door of our home or window, whatever it is, main door. Okay, main door. This is support tied with the wall. Okay, now to close it or open it, what we have to do, we need to apply force at the edge edges, right? So now when you are applying a force here, it will goes towards, or will you can open it, both will be done. Then from the center, from this support, it is at a distance, right? That distance is r. At that distance r, you are applying a force so that it is moving. Okay, when it is moves in horizontal path, that will be called as force. When it is rotating from the fixed point, then that will be called as torque. Okay, simply torque will be denoted with tau. This is pronounced as tau. So torque equal to distance into force. Okay, that distance is perpendicular distance. So this is the vector form of torque. Okay, torque equal to perpendicular distance into force where you are applied. Okay, see now let's consider one rod here. This is the fixed one. This is at a distance of r. This length is, let's consider r. So at this point you are applied a force so that it is going to make rotations. Okay, clear? So the force you have applied. So here what's happening? Torque is happening because of this force. This at a distance r, then this is going to rotate. Which is going to rotate? This rod is going to move. This rod is going to move. Okay, then that will be called as torque. Okay, let's see the definition. So torque or moment of force, the turning effect, it is rotating, no, right? It is rotating from here to here, it's making rotations, right? That is called turning effect. Turning effect of a force about a fixed point. From the fixed point only, it is rotating, right? And is measured from the product of magnitude of force and the perpendicular distance. Okay, so simply torque will be equal to r into f. This is the just formula. Torque equal to r into f. Torque tau equal to distance, perpendicular distance r into force, magnitude of force. Okay, this force only called as moment of force. Simply this total will be called as torque. Okay, clear it? Right, now what is the torque is a scalar or vector? Torque is a vector quantity. Okay, torque is a vector quantity. And what is its units? Its unit will be, r means what? Distance. F means Newton. So it's a Newton meter. SI units is Newton meter. CGS units is Dine centimeter. What is the difference between Newton and Dine? 1 Newton equal to 10 power 5 Dines. Okay, clear it? Right. Then can you tell me what is the dimensional formula for it? The dimensional formula for it is m power 1 L power 2 T power minus 2. So this is the dimensional formula for torque, okay, or moment of force. Clear it? Right. Now if in case this is the distance, this is point, this point will be called as, this point from where this total thing will be rotated, this will be called as axis of rotation. Axis of rotation. Okay, now at the distance of r from this, at this point, let's consider this is the rod, one end is fixed. So from this fixed end, it is going to rotate, this is going to rotate, this point will be called as axis of rotation. So it might be horizontal, it might be vertical, maybe vertical, horizontal, or maybe vertical, anyway. Okay, right. So this will be axis of rotation. Now I applied a force in this direction. Okay, now how to find the direction of the torque? By using right hand thumb rule. Right hand thumb rule. Okay, I think you may learnt about this in 10th, magnetic effects. There you have seen about thumb rule, right hand thumb rule. There your palm will be there, no, your palm. So your palm with your thumb. Okay, so in this, thumb represents torque here. Thumb represents torque here. This fingers represents along the direction of distance. Now if you are folding, that represents the force. So here this is the distance. Now keep your hand in the same direction, fingers in the same direction. Now curl your fingers in the direction of force. Then which direction torque will be acting? Torque will be acting here upwards. Okay, torque will be acting upwards. If I'll change the direction of force downwards, then torque will be inwards, I mean downwards. Okay, got it. It depends on the how you are considering. Okay, if upward force it is upwards, downward force it is downwards. Okay, upward force means it will be into it. Here two conditions might not be clear, na? Just listen this. Here from this point, this is the one at a distance of r. From this point I applied a force F. So this is the line of action. Sorry, this is the axis of rotation. Okay, axis of rotation. So let's consider this axis of rotation is perpendicular. This will be placed on the surface, on the plane you are placed. Let's consider that your pen is placed here. So this is the fixed point. So how the axis of rotation is upwards. Axis of rotation is upward. Okay, clear. Now when you are applying a force, how you are applying a force? Towards left, left to right, like this. Okay, when you are applying a force like this, then it will rotate in this direction. When you are applying a force downwards, it will rotate in this direction. Okay, got it. Then here torque will be produced. So torque equal to Rf. Okay, these are perpendicular distances. So torque R tau bar equal to R bar cross F bar. This simply will be written as torque equal to Rf sine theta. I will derive this right now. See. So I have one rod here. Okay, this is our axis of rotation. At this point, I applied a force. This total distance is R. So now I applied a force. I applied force in which direction? In this direction. Now it is perpendicular to the distance and it is an axis of rotation. Okay. For the axis of rotation, here what will be happen? Torque. Tau equal to this perpendicular distance Rf when it is being like this, as this angle between them is 90 degrees. Now same thing for the axis of rotation. So this is the plane at particular this point, or let's treat at this point you are not applying a force in this direction. You are going to apply force in this direction of F. Okay, if you want you can make still some very somewhat closer. We'll see. So it will be a like this. So from this point you are applying a force in this direction. You are applying a force in this direction of force. From here to what we will call distance. This is the origin point where the axis of rotation is there. Now because of this what will happen? It is going to rotate. That means some force is acting here. No, this is perpendicular and it is horizontal. This is the net force is all two components. So let's consider that angle is theta. So this will be F cos theta. If you are applying a force in this direction, is it going to rotate? No. So there will be no torque when force is acting along the direction or in this direction, opposite direction. Okay. But when you are applying in this direction, that means F sine theta is acting. So this F sine theta makes an object to rotate. Okay. Based on that, simply torque equal to Rf sine theta. Okay, still is there, just I am saying here. So from this torque equal to, according to the vector product, A B sine theta, that means it will be written as A bar cross B bar. So it will be R bar cross F bar. This is simple. Okay, vector method. Now instead of that, I will tell you in another way. This force you are applying, no? If you will draw one line, dotted line like backwards, this will be called as line of action. Line of action of force, or simply line of action. Anything it can be called. Line of action of force. From where, from which point you have considered as origin, from that point to this line of action of force, if you draw one perpendicular, then this will be called as r perpendicular distance. Okay, then if this is an angle, then what about this angle? This angle is also theta, right? How to find this distance? At what point it is? That is, I want to find this distance. Then sine theta equal to opposite side by hypotenuse. So sine theta equal to, what is the opposite side here? I want to find the perpendicular distance. Opposite side. What is the opposite side theta? R perpendicular by hypotenuse. Hypotenuse is R. So R perpendicular equal to R sine theta. So torque will be written as perpendicular distance into force. That perpendicular distance is R sine theta into F. So simply only the major formula will be torque equal to RF sine theta. If theta is 0, if theta is 0, torque will be 0. RF sin 0 value is 0. If theta is 90, torque will be RF, that is maximum. If theta equal to 180, then torque will be 0. Okay, so it is 9 at 0 it is 0, at 90 it is maximum, at 180 also it is 0. Okay, clear? This is about simple torque. Okay, right. Next, on this, for example, let's consider one object. On this is the center. Okay, let's consider center. Let's consider here one particle, here one particle. Two particles are there. So this particle is at a distance of r1 and this particle is at a distance of r2. Now I applied a force, or on this some force is acting, that is downwards, F1. On this also some force is acting, that is downwards, F2. So there are two forces acting on the two particles of masses. Okay. Now because of this here torque will be produced. Because of this here torque will be produced. Right? Correct only, no? That means here one torque is there, here one torque is there. From this, torque tau 1 equal to R bar cross R1 bar cross F1 bar. Torque tau 2 equal to R2 bar cross F2 bar. So this is the torque T1 and T2. Right? So how to find this total torque? Total torque tau equal to tau 1 plus tau 2. Vector product only. Okay. Now here I will tell you one thing very clearly. Just listen. So from this point, if there is no F1, because of this, it is going to rotate in this direction. It is going to rotate in this direction, right? If there is no this force, only this force will be there, then it is going to rotate in this direction. So because of this, what direction it is, clockwise or anti-clockwise? This direction. This direction is clockwise. So F2 is in clockwise. Then what about F1? F1 is acting in anti-clockwise. F2 and F1. So when it is moving in clockwise, when it is in clockwise, the torque will be taken as negative. When it is in anti-clockwise, this torque will be taken as, this is to, torque will be taken as positive. Okay, clockwise direction torque is negative, anti-clockwise direction is positive. Okay, so now from this, torque tau equal to R1 bar cross F1 bar. Okay, as it is taken as positive, minus R2 bar cross F2 bar. If equal forces are acting, then torque equal to R bar minus R2 bar cross product of F bar. Okay, clear? Understand? If different forces are acting but at same distance, then torque equal to R bar cross F1 bar minus F2 bar. Okay, this is about torque. Okay, now clear? Are you able to understand? Right. So let's see an example here. If a force of I cap plus j cap plus k cap is acting at a distance of 230 and then find the torque acting at 1 comma 1 comma 1. So when they are giving like this, first take the data, that is I cap plus j cap plus k cap, and at a, acting at a, that means that is a position. So RA bar equal to vector method, RA bar equal to 2 I cap plus 3 j cap plus 0 k cap. Okay, next VRB bar, RB bar equal to I cap plus j cap plus k cap. Okay, between these two difference from where to where? A acting at A, find the torque at B. Okay, now we have to do RB minus RA, RB minus RA, that is 1 minus 2. So it is minus I cap minus 1 I cap plus j minus 3g, that means minus 2j cap plus k cap, I cap minus 2j cap plus k cap. Is it right? 1 minus 2, 1 minus 3, 1 minus 0. So it is 1 k cap. So this is the R bar. So simply this is R bar. What about torque? What is the formula for torque? Torque equal to force into perpendicular distance. So torque equal to force into perpendicular. How it will be written as? It will be written as I cap, j cap, k cap. I cap will be for this force for first R. R is minus 1, minus 2, 1, and F is 1 comma 1 comma 1. Now torque equal to ij cap. So I cap of minus 2 minus 2 minus j cap of minus 1 into 1 minus 1 minus 1 plus k cap of minus 1 plus 2. So it is tau equal to I cap is 0, it is plus 2 j cap plus 2 j cap plus k cap. So this is the torque which is acting at that point. Okay, clear? Right. Ladder of mass 10 kg leans against a smooth vertical wall making an angle 53 degrees with it. Find the normal force and the friction that floor exerts. So it is placed on the horizontal surface. So it's a rough surface. It is placed on the rough surface with a smooth vertical wall. So this is smooth. That means there is no friction here. So a ladder is going to placed. So let's consider that this will be the ladder. Okay, right. So let's consider this total ladder length is L. Total ladder length is L. Can I do somewhat bigger? Yes. Now there is a wall, I mean a support on the surface, and there is a smooth wall. Okay, on this they are placed one ladder of length L, ladder of length L, and its center, it will be acting at center of mass, is acting at center. So now because of this, here one force is acting, normal force. Because of this, here is also one force is acting, normal force. Is this normal force and this normal force equal? No, both are different. Let's consider this is N1, this is N2. Here what is acting? Weight is acting downwards at a distance of L by 2. From here is also it's a distance of L by 2. Okay, right. Now they told it is making 53 degrees with wall. That means at this point it is 53 degrees. Then at this point it is 37 degrees as it is 90. Right? We can consider this 37 or not. This 53 given, no, you can follow with this or you can do with this 37. Both can be taken, no problem. But no need to take both. Any one can be enough. Okay, right. Now let's consider this point is A, this point origin point, and let's consider this point is B. So here at this point, if you consider this as a reference point, here will be the torque. If you consider this as reference point, here will be the torque. Okay, if you are consider this is reference point, here torque as well as here torque, two will be there. Let's consider torque can be considered at any point. Okay, it can be considered at any point. Fine. So now I am considering the point is at A. So at this point, torque at point A is 0. Torque at point A is 0. So what about point B? This N2 is pushing in this direction. Okay. So before that, first find the normal force. Now here N1 is acting upwards, M2 is acting, weight is acting downwards. N1 is balanced with mg. Then what about N2? N2 will be equal to, here it's a smooth wall, so there is no friction. But here is the friction is there as the horizontal surface. Okay. So in which direction friction will be acts? In this direction frictional is there. Friction force F. So N2 equal to F. N1 is mg, N2 equal to F. That's what they are asking. Find the normal force and the friction that floor exerts. Floor exerts N1. Okay. And N2 frictional force they ask us to find it. So now we'll find for that. N1 equal to mg, N2 equal to F. Okay. So N1 equal to how much? Mass is 10 kg into take the g value as 10, no problem. So N1 equal to 100. What about 100 newtons? N2 we don't know. We are about to find it out. Okay. Right. So let's see from this point, torque at point A is 0, no? Now according to the moment of inertia. So this according because of this N1 and because of this frictional force there is no torque is acting here. But see from this N2, N2 is making in this direction. So this is the line of action of force at a distance of, this is the distance, that means OB is the distance. N2 is acting, N2 N2 is the force is acting perpendicularly to the OB. That will be equal to N1 N1 which is acting at a distance, N1 is acting at a distance A, this point to here, A to some, let's consider some, this is some D, A D. Okay, clear? N1 into AD. Okay now, right? So here N1 is not acting. Now what is acting? Mg. So instead of N1 we are about to write Mg. Mg is acting at a distance of AD. Okay, now N2 into, what about OB? OB means this is the one, right? Perpendicular distance. What is this perpendicular distance for this 37? 37 perpendicular. That means I want to find the opposite side. Opposite side means sine 37. Sine 37 equal to opposite side by hypotenuse. So opposite side equal to sine 37 into hypotenuse. What is the hypotenuse? This total length L. So L into sine 37. What is the sine 37? L into 3 by 5. So this is an opposite side or nothing but OB. So OB means L into 3 by 5. That is equal to AD. AD means from here to here. That is nothing but cos 37. 7 degrees equal to adjacent side. This adjacent side only, for 37 is an adjacent side. So that adjacent side by hypotenuse. Hypotenuse is how much? Till this point only, that is L by 2. So adjacent side equal to L by 2 into cos 37 degrees. So adjacent side is mg into AD is nothing but L by 2 cos 37. Cos 37 means how much? Cos 37 means 4 by 5. 4 by 5. So 2 ones, 2 twos. Your 5, 5. L gets cancelled. So N2 into 3 equal to mg into 2. Okay. So N2 equal to 2 by 3 mg. So this is the value of N2. So N2 equal to 2 by 3 into g. Got it? So yeah, what is the mass here? 2 by 3 into mass is how much? 10 kg. Value of g is, let's take 10. So it is 200 by 3. Approximately it is 66. Okay, 66. Okay, 66 something you'll get, 66 newtons approximately. Okay, clear? So N2 is, this is the value. N2 equal to 66 newtons. Got it?